Hello! Today we're going to talk about mole conversions. This is the first of a four-part series about moles and mole conversions, with today's topic being, what is a mole? Materials needed for this video are going to be a scientific calculator. And if you do not have a scientific calculator is as simple as Googling scientific calculator on Google, and one will pop up that's available for you to use. It's a fully functional scientific calculator. So let's take a look at what is a mole. Well, the English language has lots of words that have more than one meaning, and mole is one of those. So when we talk about a mole in the English language, some people think about this guy right here, which is an underground rodent that makes annoying tunnels in your yard. And no, he's not really what we're talking about. Although you will see his clip art image on a lot of worksheets that we deal with when we talk about mole conversions. A second concept of what a mole is a dark colored pigmentation on your skin. And no, that's not what we're talking about in chemistry either. Instead, what are we taking a look at? Well, in chemistry, it is a concept similar to a dozen. A mole represents a number. A pair represents 2. A dozen represents 12. And a mole represents a number, but a much bigger number. It represents 6.02 times 10 to the 23rd. So I can have a dozen donuts, which would be 12 donuts. I can have a mole of donuts, which would be 602 billion trillion donuts. Okay, I think I'll stick with a dozen. A mole is 6.02 times 10 to the 23rd is referred to as Avogadro's number. Named after the guy who came up with the concept. Avogadro lived hundreds of years ago, but this number has been tested and remains to be true. So what do we talk about with the concept of a mole? Well, if we take a look at a glass of water, and I want to know how many little H2Os are in that glass of water, I'm going to come up with a number that is ginormous. And rather than using huge numbers in the billions of trillions of pieces, we can quantify it and say, oh, there's 2.45 moles. And knowing that there's 2.54 moles of water in a glass of water is a much easier thing to deal with than the fact that it might be something times 10 to the 23rd or 24th for the number of pieces. The number mole is based off of a concept that was originally based off of the number of pieces of carbon-12 in 12 grams of carbon-12. But currently, we define a mole just as being 6.02 times 10 to the 23rd. So when we take a look at a mole, we deal with mole conversions. We can do the same thing with donuts. And anytime we deal with a chemistry problem, it is really important to understand that chemistry problems are unit-based, not math-based. We will use math as a tool to solve the problems, but the best strategy in understanding chemistry problems is knowing how to use the units for those problems. So, anytime I see a chemistry problem, they're going to give me a number. And in this case, I have 5 dozen donuts, and I have 5 moles of donuts. And every single chemistry problem you're going to use, you can set up a fraction, because the concept is to get rid of dozen and change it into donuts. So I know that based off of my previous knowledge that 1 dozen, which I'm just going to abbreviate DZ, is the same as 12. And donuts, we'll just use DN for donuts. And I know that 1 mole of donuts, oh, by the way, mole is abbreviated as MOL. Doesn't save you a whole lot, but that's a given abbreviation. 1 mole of donuts is going to be similar, but a whole lot more at 6.02 times 10 to the 23rd donuts. Both problems can be set up the same way. You set up a fraction line. And don't let the word fraction scare you. Any chemistry problem, the number they give me, I'm going to start with. So there's my starting point. And I am going to take that unit and I'm going to put it at the bottom of the fraction line. I can do the same thing with moles and put that at the bottom of the fraction line, because the idea is to be able to get rid of moles and change it into donuts. In this case, it's dozen donuts, but in this case, it's moles of donuts. I can then use my equivalences that I have up here to fill in numbers. So I know it's 1 dozen, so I can put a 1 in front of my dozen. It's 12. I'm going to put that on top, so that's 12 donuts. And that sets up my problem. The important thing is, as a unit conversion, anything I have on the top and on the bottom can cancel out, and I have successfully changed my unit to donuts. Mathematically, these problems are not as hard as they look. Anything on top of my fraction is going to be multiplied by, and anything on the bottom of my fraction is going to be divided by. So I am going to, in my calculator, take 5 times 12, and I'm going to divide it by 1. And now mathematically multiplying by 1 and dividing by 1 doesn't change anything, so I usually skip that step. But in my calculator, I can take 5 times 12 divided by 1, and I'm going to come up with 60. So if I have 5 dozen donuts, I have 60 donuts. Now, if I have 5 moles of donuts, my problem is set up very similarly. So my unit moles goes on the bottom so it can cancel out. And I know from my equivalents that I have written up here that I have 1 mole is 6.02 times 10 to the 23rd. And it doesn't have to be donuts, it could be pieces of water. That will cause the mole unit to be canceled out and leave me with the donuts that I'm trying to figure out. Mathematically, I am still going to multiply anything on top, and I am going to divide anything on the bottom. But we need to take a little bit of a look at how to put this into your calculator, or you're going to have a lot of errors. So officially, I need to take this 5 times 6.02 times 10 to the 23rd, and I'm going to divide it by 1, and I'm going to hit equals. But if I put it in my calculator this way, I will definitely end up with some calculator errors in these problems. So let's take a look at the way your calculator is designed. Most calculators have a button to use for scientific notation. And in the most standard calculator, that button, this is a TI-30, is going to be here. And in most calculators, you're going to find the button, it is going to be EE. In this calculator, the EE button requires the second key. So I'm going to have to push second, and then I will push my EE to be able to put this into my calculator. Now, not every calculator says the exact same thing. EXP is another button, and sometimes you will see a button that says times 10 to the X. If I go back to the Google calculator, the Google calculator uses the EXP button. And how am I going to put this into the Google calculator? Well, I still put my 6.02 in normally, but I do not hit the times key. I do not hit a 10. That exponential button that I hit puts a big E on the screen. That E means times 10 and a little caret key that you might be using. So when I'm taking a look at this, I've got 6.02 times 10, and the only thing I need to type into my calculator is the power that goes along with the scientific notation, and that's how I put it into this calculator. In my calculator, it looks a little bit differently. I would still type the 6.02. I will not hit the times, I will not hit the 10, I hit the second key, and then I hit that EE. And I still only put in the power. I only put in the 23. So in my calculator, I am going to take 5. I am going to take times. I am going to push 6.02. I will push my second button. I will push the EE key. I will push the 23. And then officially I'll divide by 1, and I will hit equals. Now when this number prints out on my screen, I'm going to see 3.01. And then at the end of my screen, I'm going to see a little tiny times 10 and 24, which will be my answer. But you have to be careful on the screen, because if I have a very long decimal answer, the times 10 is going to be hit at the very end, and I've got to make sure that I see it. Anytime I multiply by 602 billion trillion, expect your answer to be in scientific notation. If I'm using the Google calculator, then I am going to take 5 times 6.02. I hit exponential, I hit 23, and then I hit equals. Now my Google answer looks a little bit differently, so let's take a look at that Google answer quickly. So your Google answer is going to say 3.01, and it gives you an E. It may be capital, it may be lowercase. It gives you a plus sign, and it gives you a 24, but it means the exact same thing. In math, an E symbol is frequently used to represent scientific notation, just like it's an E here. So, how many donuts do I have? Well, I have 3.01 times 10 to the 24th donuts. In the remaining parts to the video, we will get more practice on how to use these calculations. So if you don't feel quite comfortable with it, know that you're okay. We're going to get you to where you need to be.